When you see that famous C logo, you probably think of the bulletproof iron and a million-mile engine that refuses to break. But for its first 20 years, this legendary company didn't make a dime. It was a massive money pit kept alive by a former family chauffeur. How did a struggling Indiana workshop go from building temperamental farm pumps to dragging 60,000-pound Sherman tanks out of the mud? And how did that exact same iron spark a rabid lifestyle cult, only to trigger a historic $1.6 billion fine? Today, we're tearing down the gritty 100-year history of Cummins. From brilliant mechanical breakthroughs to a 20-year war with the EPA, here's how underdog iron built America. To understand how Cummins is surviving today, you have to see how close they came to dying in 1919. It started with what looked like a golden ticket. Sears Roebuck ordered 4,500 engines from the young company. These weren't massive industrial power plants, but small single-cylinder units branded as the Thermoil, built for farmers to run pumps, saws, and grinders. On paper, it was the deal that put Cummins on the map. In the dirt and grease of reality, it was a disaster. The Thermoil relied on a temperamental licensed design known as the FEUD oil engine. It purred in a clean workshop, but out in the mud of a working farm, the intricate fuel metering choked, leaving farmers with a starting nightmare instead of the simple, abuse-proof iron they wanted. The engines didn't just sit on shelves, they came back. Farmers returned them in droves. Sears canceled the contract. Clessey was left with a warehouse full of dead iron and a $40,000 hole, a massive hit for a 1920s startup. Most backers would have walked, but William Irwin wasn't just a banker, and Clessey wasn't just a part-time family chauffeur. Clessey was a pure, self-taught gearhead. After dropping out of the 8th grade at age 16 to become a machinist, he built a primitive steam engine using shotgun shells as cylinders and pennies as pistons. He spent his early years turning wrenches across Indiana, even working in the pit crew for the winning car at the very first Indy 500. Irwin helped finance Clessey's car repair business in 1913, which grew into machining artillery wheel hubs during World War I. Irwin knew the kid's sheer mechanical grit, so he wrote the check and kept the lights on. Realizing licensed designs were a dead end, Clessey went back to the shop to fix the diesel engine's core flaw, the knock. Early diesels were violent. To ignite fuel without a spark, they relied on massive compression ratios, often 16:1 or higher. Inject the fuel and it detonated all at once. That pressure spike slammed the piston down, creating that distinct hammer-like diesel knock. To contain the violence, blocks had to be cast from thick, heavy iron. That weight penalty meant diesel was stuck in stationary plants or massive ships, way too heavy for a truck frame. To get diesel on the highway, Clessey had to tame the combustion. The fix wasn't some licensed pre-chamber nonsense. It was Clessey's own mechanical direct injection system. He built a cam-driven plunger to blast fuel at 5,000 psi, pairing it with a sneezer air cell in the piston to blow the injector clean and create massive turbulence. This smoothed the violent detonation into a heavy push, allowing blocks to be cast lighter and RPMs to climb, transforming the diesel from a slow anvil into a high-speed highway power plant. The real magic was Clessey's own single-disc rotary fuel pump and unit injectors. Instead of clogging, the system metered the fuel perfectly, keeping the engine firing under heavy load. But having the tech was only half the battle. By 1930, the Great Depression hit. Truck builders weren't gambling on unproven expensive engines. If no one would buy it, Clessey had to shove it in their faces. He traded engineering for sheer showmanship. In late 1929, with the stock market wiped out, Irwin was ready to shut the company down. Desperate to save his life's work, Clessey secretly bought a used Packard limo, tore out its gas engine, and shoehorned a 50-horsepower Model U marine diesel between the fenders in a hidden garage. On Christmas Day, he rolled it up to Irwin's house. Irwin was furious at the unauthorized spending, until he took a ride and realized what was under the hood. He was ecstatic. It was loud and shook like a wet dog, but it was the lifeline the company needed. With Irwin back on board, Clessey drove the beast to the New York Auto Show. This survival and subsequent stunts paved the way for the industry-defining Model H, a 672 cubic inch inline six, churning out 125 horsepower that would literally build the American trucking industry. While the country was starving, Clessey rolled into New York with an impossible headline. He pushed that heavy luxury barge 792 miles on just $1.38 worth of furnace oil, getting nearly 30 miles to the gallon. Next stop, the Indianapolis 500. Clessy contracted his friends Fred and Augie Duesenberg to build a custom race car. In 1931, the racing elite laughed at this Cummins diesel special. Starting in the middle of the sixth row, it was heavy, sounded like a tractor, and couldn't match the top speed of the gas-burning thoroughbreds. But Clessy didn't plan to outrun them. He planned to outlast them. While the gas cars chewed through tires and burned fuel at a frantic pace, endurance driver Dave Evans wrestled the heavy steering wheel of that smoking diesel, quietly laying down laps. It became the first car in history to run the entire 500 miles without a single pit stop. It finished 13th, averaging 86 miles an hour. It didn't take the trophy, but it won the argument. Gas couldn't touch diesel's endurance. To prove it wasn't a fluke, Clessy put a diesel in a truck and ran a grueling endurance test. Fuel, maintenance, and driver changes were all done while moving. The truck ran for 13,500 miles without the wheels ever stopping, and the engine ran for 14,600 miles without being shut off. Even with the headlines and the engineering breakthroughs, the ledger bled red. The money pit kept eating Irwin's fortune. By the late 30s, the company was 2 decades deep without a steady profit. Market skepticism was thick, and diesel infrastructure was barely there. Cummins survived on a banker's patience and an inventor's stubbornness. But outside Columbus, Indiana, the world was darkening. As 1939 closed, industrial priorities shifted violently. The days of begging farmers to save a few pennies were over. A new, insatiable demand was rising across the ocean, retooling the machinery of peace for war. The money pit was about to become a strategic asset. When America entered World War II, the bottom line stopped mattering. Raw tonnage was all that counted. For Clessy Cummins, the war brought a direct summons to Washington. Recognized as a national asset, Clessy took charge of the War Production Board's internal combustion engine section, putting the nation's logistics first by handing precious raw materials to competitors, just to get reliable horsepower to the front lines faster. While the military relied heavily on gasoline for frontline tanks to keep supply chains simple, the massive logistical infrastructure of the war ran on Cummins diesel. They provided the heavy-duty power for remote airport construction, deep desert operations, and the grueling effort to carve out the Alaska Highway. They built the massive power generation systems that kept vital military radar arrays scanning the skies. Their efficiency and relentless cost control were so absolute that the Navy awarded Cummins the prestigious E Award for excellence in production. By 1945, the debate over commercial power was over. Diesel was king for heavy transport, and the money pit finally started turning real profit. By 1945, Cummins was a global heavyweight that needed to scale, but Clessy didn't want to be a corporate manager. He voluntarily stepped back to California to focus on pure design, handing the boardroom keys to J. Irwin Miller, the original bankroller's great-nephew. So Clessy could keep wrenching. And Clessy didn't waste that time. His biggest contribution to the long-term success of the company hit the market in '54, the pressure time or PT fuel system. By metering the fuel with line pressure and a camshaft lobe, his design squeezed out raw efficiency that left the competition choking on black smoke. This exact system became the mechanical foundation for the company's massive breakout performance in the 60s and 70s. While out in California, Clessy finally had time to solve a problem that had haunted him since back in '31, when he nearly put a truck off a cliff on California's Cajon Pass. But he knew firsthand the sheer terror of hauling 80,000 pounds down a steep grade. Standard drum brakes cooked fast, and once that friction material glazed over, your rig turned into a runaway missile. Clessy found a dead simple fix. By altering exhaust valve timing, he turned the diesel block into a giant air compressor that fought the wheels, dragging 80,000 pounds to a safe speed without ever smoking the brake shoes. He pitched this safety revolution to the Cummins board as a hard requirement for heavy hauling. Their answer? Cummins management respectfully passed, believing their focus needed to remain strictly on making trucks go, not stopping them. Clessy didn't blink. He walked his blueprints to Jacobs Manufacturing, a drill chuck company. They saw the genius the board missed. They licensed the tech, and the legendary Jake brake was born. That decision haunted Cummins accountants for 60 years. The Jake brake became a mandatory iron. Because the boardroom rejected their founder's invention, Cummins had to pay to buy the brakes back from Jacobs to bolt onto their own engines. For decades, they paid a markup on tech invented at their own shops. Despite missing out on manufacturing the Jake brake, Cummins was sitting on a gold mine. The war proved their diesels wouldn't quit. The post-war boom built the factories. As the 1950s closed, America geared up for the biggest dirt-moving job in human history. Two-lane blacktop was out. The interstate highway system was coming, and it was going to be paved with diesel power. To pave that new interstate system, the company rolled out the NH220. That legendary 743 cubic inch block became the undisputed king of the American highway, proving the suits might run the boardroom, but Clessy's iron still ran the roads. But conquering all that newly poured concrete meant trucking needed more than raw horsepower. It needed dead-on reliability. The soot-stained days of early diesel were over. Transcontinental logistics meant an engine had to survive thousands of hard miles without skipping a beat. Cummins had to grow up. They went from a scrappy inventor's workshop to a global powerhouse, and the guy leading the charge wasn't a grease-covered mechanic. He was a businessman who knew a company needed a soul just as much as a solid balance sheet. J. Irwin Miller ran this golden era. He was William Irwin's great-nephew, but an anomaly in heavy industry. He was a scholar and a patron of the arts. To attract the lead engineers to a corn-fed Indiana town, Miller championed a radical idea. He transformed Columbus into a modernist architectural mecca, proving Cummins valued forward-thinking design just as much as raw horsepower. It was a place where the future was being forged. One of those elite minds was Dr. Julius Purr, a Hungarian refugee who bolted from behind the Iron Curtain. He found a home in Miller's shop. He submitted over 300 patent applications during his career and was officially granted 186 of them, beating even Clessy Cummins' own record. While Clessy laid the foundation for the pressure time or PT fuel system back in the 50s, Purr and his engineering team spent the 60s perfecting its internal mechanics. In the 60s, diesel injection was a plumbing nightmare. Competitors used fragile, high-pressure external lines that vibrated, cracked, and spewed diesel everywhere. The PT system scrapped all that. P stood for pressure, T for time. A simple gear pump fed fuel to a common rail at a low, steady pressure. No more high-pressure line blowouts. Driven mechanically by the camshaft, the injector acted like a computer, dialing in the exact combustion event based simply on rail pressure and how long the plunger stayed open. Because the high pressure was built inside the injector, right at the point of ignition, the plunger slammed fuel into the cylinder at over 20,000 psi. That sheer force atomized the diesel into a microscopic mist. It burned hotter, cleaner, and hit harder than the sloppy coarse spray of older rigs. It was bulletproof, and interstate haulers ate it up. And out in the shops, grease monkeys quickly figured out you could swap the small calibration buttons inside the injectors to easily cheat the system and crank up the horsepower. The PT system found its ultimate home in the N series, specifically the legendary 855 cubic inch inline 6. The 855 quickly became the industry yardstick. Then, the 1973 oil crisis hit. Diesel prices went through the roof, and running a thirsty rig meant going bankrupt. Fuel efficiency went from a luxury to a matter of survival. Cummins answered with the big cam 855. They bumped up the camshaft diameter. This let them shorten the injection time while jacking up the pressure. That one shift in geometry changed everything. The big cam delivered a razor-sharp throttle response and kept the smoke down. Most importantly, it squeezed miles out of every drop of fuel. Drivers could lug it down at lower RPMs, cruising 80,000 pounds of freight comfortably without burning up their paychecks. This wasn't just some sluggish iron lump. A dialed-in big cam easily laid down 400 horsepower and over 1,200 pound-feet of torque. It had the sheer twisting force to yank a loaded trailer up the steepest grades without breaking a sweat. But they didn't just stop at one revision. Cummins kept tweaking the formula through the Big Cam 1, 2, and the legendary 3 before they pushed the architecture too far, hitting a brick wall with the notorious coolant flow headaches of the Big Cam 4. The market didn't just react, it surrendered. By the early 80s, the Big Cam 855 owned 63% of the heavy-duty truck market. Look at any Peterbilt, Kenworth, or Freightliner hammering down the interstate back then. Odds are it had an 855 sitting between the frame rails. The deep, rhythmic thud of that inline 6, backing down with the violent machine gun bark of the Jake brake, became the soundtrack of the American highway. That 855 block didn't just move freight, it literally pulled the economy. But Cummins wasn't immune to a bad bet. Cummins was losing ground to the infamous Screamin' Jimmy 8V71s from Detroit, engines that sounded like they were turning a million RPMs while just sitting at a stoplight. Trying to chase the lighter, screaming two-strokes from Detroit diesel, Cummins strayed from their inline-six roots and built the V903. It was a compact V8 diesel built to cram maximum horsepower into a shorter block. On paper, the high power-to-weight ratio meant fleets could haul more freight. In the dirt, it was a disaster. Lacking the low-end grunt of the 855, the V903 felt like a sports car engine strapped to a heavy hauler, tearing itself apart faster than the trusty inline-six. On the highway, the V903 tanked. Fleets ran back to the 855, but Cummins didn't scrap it, they pivoted. The same traits truckers despised, the compact size and high revs, were exactly what the U.S. military wanted. The V903 found its true home sitting deep in the hull of the Bradley fighting vehicle. Cummins flipped a commercial flop into a massive defense contract, moving heavy armor across the battlefield instead of freight down the interstate. By 1979, Cummins owned the industrial world. Miller's vision, Purr's engineering, and the Big Cam's profits proved the stakeholder model worked. They built a utopia in Indiana and an empire on the asphalt. But comfort breeds blindness. Cummins banked heavily on the post-war boom lasting forever. They were about to learn that in heavy industry, gravity always wins. The 80s recession was looming, ready to punish complacency with brutal efficiency. The next decade wouldn't bring a victory lap. It would bring a street fight for survival. The fight arrived in the form of a double tap, a brutal recession and a foreign invasion. By the early 1980s, the Japanese industrial giant Komatsu had set its sights on the American heavy equipment market. Komatsu was a formidable adversary, backed by a weak yen that allowed them to undercut American manufacturers on price while offering high-quality hardware. For Cummins, this wasn't just competition, it was an existential threat. If Komatsu gained a foothold in the North American engine market, they would be nearly impossible to dislodge. The response from Cummins chairman Henry Schacht was swift, decisive, and incredibly painful. It was a brutal pricing strategy that industry watchers essentially called a scorched earth defense. Schacht realized that trying to maintain high profit margins while losing market share was a death spiral. Instead, he chose to cut engine prices by 30% across the board. It was a move that horrified the accountants. On paper, it looked like financial suicide. Accepting massive losses, the company willingly obliterated its own profitability to match Komatsu dollar for dollar, denying the enemy the oxygen they needed to survive. By removing the pricing advantage, Schacht forced customers to choose based on service, reliability, and existing relationships, areas where Cummins still held the high ground. The plan worked. Komatsu failed to capture the dominant market share they needed in the dirt to justify their expansion. Schacht bled them out in the heavy equipment sector, ensuring the Japanese giant never even got the chance to mount a threat on the American highway market. Cummins had held the line, but the cost was staggering. The company was bleeding cash, the workforce had been slashed, and the money pit days seemed to be returning. They needed a miracle, and they found it in the most unlikely place, a failing pickup truck division. In the late 1980s, the Chrysler Corporation was in dire straits. Their Dodge Ram pickup trucks were distant thirds in a two-horse race between Ford and Chevy. The trucks were dated, the styling was boxy, and the engines were lackluster. Dodge needed a differentiator, something that would grab the attention of the American working class. They looked at the Cummins B-Series, a medium-duty chunk of iron cutting its teeth in Case Corporation tractors, thanks to a massive joint venture, and asked an absurd question. The engineering challenges were significant. The thing was tall, heavy, and it clattered like an empty school bus. But when the 1989 Dodge Ram launched with a 5.9-liter 6BT Cummins turbo diesel, it didn't just turn heads, it snapped necks. To understand why this was revolutionary, you have to look at the numbers. At the time, a big block gasoline V8 might produce decent horsepower, but it had to scream at high RPMs to move a heavy load. The 6BT was different. It didn't scream, it grunted. It slammed down 400 pound-feet of torque at just 1,700 RPM. You could hook a trailer to a Dodge Ram and accelerate up a hill without the engine ever breaking a sweat. It delivered semi-truck characteristics in a consumer package. But all that low-end grunt came with a nasty side effect. The engine was practically bulletproof, but it loved to shred the weak Dodge automatic transmissions bolted directly behind it. This partnership didn't just save Dodge, it birthed the cult of the 6BT. Suddenly, this inline-six iron block wasn't just for farmers, it became a hardcore lifestyle brand. They wore the C logo on their hats, tattooed it on their arms, and engaged in fierce rivalries with Ford's Power Stroke and Chevy's Duramax owners. And while the later trucks get all the glory, the true disciples know it started with the Bosch VE rotary pump. It didn't make insane power right off the lot, but with a couple of turns of the wrench and a ground-down fuel pin, guys were waking up those early first-gen Rams and blowing the doors off gas job V8s. But the real magic hit in '94 with the Bosch P7100 injection pump. That massive mechanical P-pump was the holy grail for tuners, letting guys crank out insane horsepower gains with just a screwdriver and some free time. However, membership in this cult required a certain level of mechanical masochism. The 12-valve and 24-valve engines of this era were legendary for their durability, but they were also famous for their specific catastrophic flaws. The bond among Cummins owners was often forged in the garage, sharing solutions to problems that the factory had overlooked. The most notorious flaw was the killer Dowel Pin, a tiny steel alignment pin that vibrated loose and dropped into the timing gears, blowing a hole straight through the aluminum case and turning the engine's guts into shrapnel. The factory ignored it, so the community stepped up, throwing KDP jig parties to install a 50-cent metal tab before the engine could grenade itself. If you bought a used 12-valve, the first question wasn't how are the tires, it was, has the KDP been fixed? This era solidified the image of the Cummins engine as an imperfect but immortal beast. It was an engine that you had to understand to operate. It vibrated, it was loud, and it might try to kill itself with a dowel pin. But if you treated it right, it would run for 1,000,000 miles. The flaws gave it character, but its cast iron guts made it a legend. By the time the new millennium arrived, Cummins had successfully pivoted. They were no longer just an industrial supplier. They were the heart of the American heavy-duty pickup market. The scorched earth policy had preserved their independence, and the Dodge partnership had secured their future. But while the engineers and the enthusiasts were focused on horsepower, torque, and dowel pins, the ground was shifting beneath their feet. The era of mechanical tuning and rolling thick black soot was coming to an abrupt end. A new adversary was drafting regulations that would demand a level of precision that iron and gears alone could not achieve. The regulators were coming for the diesel engine, and this time, the threat wasn't coming from a competitor across the ocean, but from the air we breathe. The next battle wasn't fought in the boardroom or on the track. It was a 20-year siege between thermodynamics and the EPA. For a century, engine design was simple: make more power and burn less fuel. But when the infamous 1998 EPA consent decree dropped, it forced them to meet strict new standards by 2002, slamming them with a third conflicting variable: drastically cleaner air. By 2010, this plumbing added roughly $17,500 to the price tag of a single heavy-duty engine. All the extra plumbing, filters, and fluid tanks slapped over 500 pounds of deadweight onto the steer axle, robbing truckers of payload and profit. And the EPA didn't just attack the iron. In 2006, they mandated ultra-low sulfur diesel, stripping away the thick lubricity that old mechanical injection pumps needed to survive. To clean up the burn, engineers had to atomize the fuel like never before. They fully abandoned the old mechanical racks and those fragile rotary pumps, shifting entirely to high-pressure common rail systems that hammered diesel into the cylinders at over 30,000 psi. The regulations were so brutal, they actually forced industry giant Caterpillar to abandon the highway market entirely in 2008, leaving the road to Cummins. But staying in the game meant hitting the physics wall. To cut emissions, Cummins relied on exhaust gas recirculation, or EGR. The idea was simple but brutal. Take hot, soot-filled exhaust and shove it right back into the intake. Pushing all that exhaust required variable geometry turbos that quickly jammed with hard carbon, choking out boost, while the extreme heat forced trucks to run massive 1,200 square-inch radiators that permanently altered heavy-duty hood designs. It worked for the air, but it was absolute torture for the iron. Extreme thermal shock routinely cracked heat exchangers, dumping raw coolant into the cylinders and hydro-locking engines. Meanwhile, soot turned the oil into a grinding paste, forcing the invention of the CJ4 low ash oil just to prevent crankcase sludge from turning to concrete, cutting those legendary million-mile lifespans in half. 80 years of brand loyalty was suddenly on the line. And it wasn't just the tailpipe they choked off. They slapped restrictive crankcase ventilation filters on top of the valve cover, which would plug up, pressurize the block, and literally blow the rear main seal right out of the engine. Worse yet, this war didn't just hit the big rigs. It forced Dodge and Cummins to kill off the legendary 5.9-liter mid-year in 2007. They couldn't just bore the cylinders out. They had to lengthen the stroke too, punching it out to a massive 6.7 liters just to handle the suffocating back pressure of the new DPF filters. Truckers were furious. They were paying way more for engines that broke down faster, weighed more, and burned extra fuel just to regenerate choked filters. And to clean those choked filters, the engine dumped raw fuel straight into the exhaust, blasting tailpipe temperatures north of 1100 degrees Fahrenheit, and turning the stack into a literal blowtorch. Regeneration only burns off the soot. Over time, non-combustible ash tightly packed the ceramic honeycomb, forcing shops to yank the 80-pound filters out and bake them in industrial kilns. And just when guys figured out the soot filters, 2010 hit, forcing them to pump corrosive urea-based diesel exhaust fluid from a 15-gallon plastic tank just to keep the truck moving. If a single NOx sensor got dirty, the computer threw the engine into D-rate, chopping your 500 horsepower down to a limp and stranding an 80,000-pound rig on the shoulder at 5 miles an hour. This sparked an underground resistance. At first, guys exploited the glider kit loophole, dropping rebuilt pre-emissions blocks in the new chassis. But soon the rebellion moved to the garage. With a wrench and a tuner, owners ripped out the restrictive plumbing, rewrote fuel maps, and deleted the emissions equipment to turn choked-out bricks back into fire-breathing torque monsters. Results were staggering. Without the engine choking on its own exhaust, reliability returned. Fuel efficiency jumped by nearly 20%. It was civil disobedience with a wrench, making the deleted truck the absolute gold standard on the used market. But the government was watching. The EPA cracked down hard on the delete culture, targeting shops and tuners. The message was chilling. The backyard tuner era was dead. You couldn't outsmart the feds with a laptop anymore. Cummins survived and eventually fixed those early emissions failures, but the landscape had changed. Engineers realized they were hitting the mechanical limits of combustion. Squeezing that last 1% of efficiency out of a piston was getting astronomically expensive. To survive, they couldn't just scrub the exhaust. They had to rethink power itself. The piston brought them this far, but to keep the lights on, they had to look beyond the diesel tank. Chasing a fix beyond the fuel tank led them into deep water. In the high-stakes poker game of modern emissions compliance, they tried to bluff the EPA, and they got caught. In late 2023, the Department of Justice dropped the hammer. The struggle against physics had turned illegal. The company hid software on 630,000 Ram trucks running their legendary 6.7-liter turbo diesels to bypass the emissions scrubbers. Buried in millions of lines of code, a digital defeat device looked for steady-state highway driving to quietly choke off the DEF injection and DPF soot traps, saving fuel at the cost of illegal emissions. The penalty hit hard. They were slapped with a record $1.675 billion civil fine, and the total bleed crossed the $2 billion mark once the environmental remedies were paid out. That's the largest civil fine in the history of the Clean Air Act, trailing only the Deepwater Horizon oil spill for environmental payouts. J. Irwin Miller's ethical gold standard was shattered overnight. It proved even the most trusted names break under the crushing weight of impossible regulations. But the real test of a legacy builder isn't avoiding a scandal, it's surviving one. Leading the charge is CEO Jennifer Rumsey, who inherited a company that knows how to survive by placing massive bets. Years before she took the wheel, the company's biggest gamble was the QSK-95, codenamed Hedgehog. The goal? They gambled $300 million on a massive 95-liter, 4,000-horsepower V16 Brute that critics said would never pay out. They built it anyway, and the Hedgehog found a home nobody saw coming: the Internet. Today, the QSK-95 is the backup muscle for the world's largest data centers. When you stream a video or check your bank account, there's a good chance a $4,000 horsepower diesel is sitting in a cold concrete basement ready to roar to life the second the grid drops. That Indiana iron is the silent backbone of the digital economy. But keeping the servers humming is only half the battle. The real threat is the fuel itself. As regulators try to kill off the internal combustion engine, the company rolled out the Helm platform. It hinges on the agnostic block, rolling out first on their legendary 15-liter X15 architecture. The engineers realized the heavy bottom end, the block, the forged steel crankshaft, the connecting rods, doesn't give a damn what fuel is burning above it. They cast a universal lower block to keep costs down, allowing them to bolt on specialized cylinder heads depending on the fuel. By simply swapping the head, the exact same base engine can burn traditional diesel, spark-ignited natural gas, or zero-carbon hydrogen, bridging the gap to a zero-emissions future. Fleets can transition at their own speed without ditching the heavy-duty iron they've trusted for a century. Weathering billion-dollar fines, pivoting from highway trucks to server farms, and rebuilding the piston engine for a hydrogen world takes serious grit. They're playing a much longer game than the competition. And while this American giant fights to reinvent the wheel on the highway, it proves that the real revolution isn't just changing the fuel, it's about having the iron to survive. The Cummins story runs deeper than cast iron and horsepower, and it all goes back to Klesse Cummins' pure, stubborn refusal to quit when everyone else said diesel was just for ships and stationary pumps. From the money pit to the emissions war, they traded that thick black exhaust for a cleaner, wired-up future. Facing Destination Zero, they have to gut the very combustion process that made them legends to keep the assembly lines running. Can this new era save the mechanical soul of Cummins, or is the age of heavy iron finally dead? Let us know in the comments.